So hello everybody, again I'm Joe, and I'll be talking a little bit about the business intelligence and analytics in our company, how we deal with data, because we have a lot of data, and it's kind of important, also difficult to use it properly, to actually know what's actually happening in real time, also in on a longer term in our company. So I will start with the history a little bit, how it was happening before, like just to have an overview. We have a lot of separate developers teams, one for search, one for booking, another for automation jobs, another for customer support assistants, and I don't know, a few others. Each of these teams, of course, they are cooperating, but they are also quite separate, and they all have their own, I don't know, some database or some other data source where they put their data and how they work with it, or where they work with it. Also, they don't really, like, it wasn't on their mind, or when they were creating their data sources, databases, to actually do some analysis on it. It was stored in the way their systems needed it, so doing any analysis on those systems wasn't very, I know it wasn't designed for it, so it wasn't simple. It needed some ad hoc scripts and stuff. So just some illustration how it might have looked in the beginnings or in the early years of the company. Basically, Oliver, our CEO, would ask these developers who are doing their stuff, like how many bookings do we have, or how are we doing, how did we do yesterday, and people just randomly try to answer. One would say a number, and another number, yet another number, even some range of numbers, or just don't care at all about it. And like at the time, it was enough for the CEO to just say thank you, maybe make some average, I don't know, but that was all the information he could get in the beginning, so he probably had to be happy with it, or just was not thinking about it at that point. It was not that important, but also how does infrastructure look like? Like I said, there is these many systems, and whenever we actually try to like answer a question for Oliver, for our CEO, we had to just sit and write an ad hoc script for even simple stuff like, I don't know, for one route from London to New York, how many searches get converted to a booking, something like that. So it would require writing a script that would run on several databases, and sometimes, of course, most often it would be good, but sometimes it just oftentimes would happen that the database would break or just get stuck. Then people couldn't book for a while, or just the search engine would get slow, the website would get slow. So these problems were frequent. It wasn't something unusual. So basically, that's why people in the company we decided to do something about it, and we started. We realized let's build some, I don't know, sophisticated solution, some dedicated database, dedicated I know, scripts, systems, but we still didn't have that many people for it yet. It was at a time where the company had, I don't know, maybe 40, maybe 50 people total, whereas now there is more than 1,500. So what happened was that a couple of engineers who were working on, I don't know, booking, search, other stuff, that just did this sophisticated sort of tries for analytics in their free time, or just in the, I don't know, after hours and stuff. So also, of course, it was better, but it was still a lot of failures, and so this illustration shows what oftentimes happened, that we built something, but it just didn't fit. It was good because it did something, but still not good enough, and people did not have the time or energy to fix it every time. So it kind of, I don't say failed, but it wasn't great yet. So people realized that we actually need some dedicated people who wouldn't work on other stuff and do analytics in their spare time. So actually we created a new team of analytics and BI together. At that point was in the beginning, I think 4 or 5 of us. And we were given a lot of, free space to play with tools, to, run around some scripts, to do whatever we needed with data. So yeah, we had fun times. We are just basically building a new city or a new stuff from the beginning. A lot of it burned, a lot of it didn't burn, a lot of it stopped being useful. But we wanted to try all of stuff. We did. It was cool. And so just to present maybe a few tools or a few stuff what we tried. One of it, and we still have it, this is a core part of our system, is Airflow. Maybe how many people heard about Airflow? Can you raise your hands? Yeah, great, cool. So for those of you who don't know it, it's it's a scheduling system. Why we needed it? When we have all those systems or databases or even external sources where we take data from, we need to somehow be getting to our analytical database. And like in the beginnings, we used mostly cron jobs or other solutions like that. Also, there were other problems that the data sources, they didn't have, that there wasn't any way how to do some incremental updating because we couldn't recognize how to get like what data are new, what was updated, what was not. This all needed re-implementing of the, or adjusting of the sources. We had to add new like timestamp columns, updated columns, stop doing hard deletes, and other minor things that I can't even remember now. But all of it, like of course not everything, but most of it, Airflow helped us with because it's a Python tool, and even the way you write jobs in it, it helps you think about most of this, not all, but most of this stuff. And of course it has nice UI, it has some alerting and everything. So now we started being aware of at least, maybe actually it added us some more fuck-ups, but at least we were aware of the problems that we didn't know before. Of course, there is our core systems are all, or most of them are based on PostgreSQL databases. Not all of them, we have some other, but most of it is on Postgre. Then also we, like previously, when we are doing some analytics, the output was usually just, random text file or CSV or just email at best. But then we started doing it more sophisticated, whatever. We wanted some tools to actually visualize or give the data to our CEO, to other people who are doing decisions. So we implemented or just started using Metabase, which is open source, very simple, or quite a simple tool, but it can do a lot of stuff, even though it doesn't look like it at first. It's easy to work with. Also, Kebula was another ETL system. This time it was in cooperation with GoData, which is more robust than Metabase, but for some reporting, maybe good, definitely used for some people in our company. Also, we started using BigQuery for some larger data, especially for our searches, which is really a huge number of them. Andre already said the numbers, I think 20 billion per day or something of the data. He will talk a bit more about it later. Also, for this, we also needed some queues like Redis and Kafka maybe, or PubSub. Andre will talk about it later more. So right now, after we started using all of this, there were still a lot of problems, but at least we had some, more robust solution. A lot of it had problems with stability, with fuck-ups. They are still there, but we are figuring it out. And so we are now getting to the current state of our analytics and BI. First, I will just I wanted to introduce the team because we were like four, yes. Now actually we split the former analytics into analytics and BI team, where analysts are really the people who do the statistics, analytics, and reporting, and the BI team are this mostly us who are doing the development part. Like we are preparing the data flows, the pipelines, so that they actually have something to work with and reliable stuff to work with. So their analytics and BI is now probably something like 30 to 35 people, I'm not seriously sure, something like that. I was trying to actually find some pictures from our offices where we would just be, working or something, but it proved hard. I only was able to find mostly pictures from some, I don't know, parties or team buildings. So here you go. Just moving on is the current state and some basic overview of the architecture. What we have now, it's mostly what I was talking about, but just to have it on a picture. There is many sources. Just here are just 4 or 5 of them. I think we have at least like 8, 9 internal databases. When I go through my data grip, I have to scroll a lot of times to see all the sources. That's just internal, and of course there is something from internet. Like maybe we need to know currency exchange rates or whatever else that is public, but we need to use it. The core is our analytical database. It's based on Postgres and the Airflow system that's doing all the jobs, all the transformations, synchronization stuff. Then there are the analytical tools like Good Data, Excel, of course, as well, Metabase, Tableau, maybe other. And then there is also some dashboard tools, which I don't even remember now, that are not really, they are basically for reporting, but it doesn't change that often. Just because Airflow is really quite integral for us, I wanted to show and maybe talk a little bit about the batch data processing. This is what we are looking at it now is just some screenshots from the Airflow. This is some so-called DAGs or directed acyclic graphs, which are just dependency graphs for the system that tells which jobs are dependent or waiting for other jobs. So we can have a simple one like the one in the bottom left, where just 4 jobs, one waiting for all 3 of other of them, or a much more, I don't know, bigger, complicated one on the right, where this our core table called booking call version 2 requires probably something like 25, 30 jobs to finish before it can be calculated. Just wanted also to mention the idea of batch or of the processing of data, batch versus streaming. In this case of Airflow, or what I'm mostly talking about, it's all batch processing, where we just run our jobs some interval, every 1 hour, 1 day, 10 minutes, that's most often, where we just look into the source databases, check what's new, check what's updated, just take it and put it to our analytical database just every 10 minutes. Take, put. Whereas, of course, the streaming is where there is just running stream of data coming to some queue or some processor that has to consume it and work with it as it is coming. Andre will be talking more about it, so I won't. Moving on, this is what we are basically. Okay, first our team is split. Our BI team is split into now more, I don't know, sub teams for provisioning of data, experimentation, like quality also. Yeah, the quality is actually new. And here are some pictures that illustrate what we are mostly focusing on recently. First one, the SLAs or service level agreements. I actually quite hate it, but it's important for us to make sure that. I mean, I don't hate the concept. I hate the shortcut. But it's important for us to guarantee some level of reliability of the data, also some maybe timing, so that analytics are sure that they can run their reports at some time, and we have to guarantee data are there, they are reliable, and stuff like that. So right now we are in the process of setting a lot of these SLAs for multiple of our processings, as well as the whole stuff at once. Of course, also we need much more alerting for that, so we are using PagerDuty to call us or just notify us whenever something breaks. And since this is really disturbing when we are sleeping, for example, we have added extra motivation to do something about it. Like when something calls you at 3 a.m., you really then work hard to prevent it in the future. And also we are more and more using the power of cloud computing. Previously we used to use more like traditional virtual servers hosted somewhere. Right now we are much more using Amazon or Google Cloud services, mostly probably Amazon right now, where we can scale much more easily. Like we had several times we used to have problems with our database growing much quicker than we expected, and moving the database from one normal virtual server to another. It's kind of painful. Of course, it's nothing extremely, but there is extremely difficult. But there is some downtime. It's just every time, I don't know, painful to do. So, like on Amazon, we just basically add more space just by clicking a few times. Usually, there is even no downtime required. If there is, just switch to our. Like we usually have a master database and a slave database, so we switch to the other one, upgrade the first one, and we don't even do any downtime, or at worst a few seconds, but usually done. Of course, also logs are important to us. They're always important, but previously they were just usually on the server and really hard to work with. Recently we started using some services like Sentry or Logs.io that make it much more easy, way easier to visualize this stuff. Maybe, for example, in the case of Logs.io in Elasticsearch or in Kibana, where I can just search for some error and see it in maybe bars and see how some change increased or decreased the number of errors per day, for example. So that's what we are currently mostly focused on, and so what's in the future. So our goal is to, maybe I will first stay here. Our goal is to just of course, make the data way more reliable, but also way more understandable, and also how to say, accessible to as many people as possible, because now our company is now big, and previously only very few people had access to all data or were able to use the access. Now it's way more, but still probably not enough. So our ideal goal would be for most of the data to be available to most of the company, and most of the people understanding it in the same proper way, so there will be any confusion. But this is always quite a challenge, because even in between our teams, people have different naming conventions, different views of the data, because they are very focused on what they do, but they don't quite know exactly what other teams do with data. So what of course is the possible threat is that we will be providing data, but we will maybe do incorrect naming, or we will not explain them properly, don't document, don't share the documentation properly, and it might happen that if each of these guys, gentlemen, is a team in our company, it may happen that the teams will consider or take the same data, but explain it for themselves in different ways, and then whenever there is a strategy meeting, people will just don't just argue, and if that happens, then boom, apocalypse, and we are done probably, but I hope this is not going to happening. So our future in our mind is much nicer, where we hope people will understand the stuff what we are providing, and just whenever there is a company-wide or bigger meeting between the team leaders, they will know, they will have the same access to same data and understand them, and there will be ideally fruitful discussion that will lead to good strategy decision that might help us later in the future. So I'm getting to the end. Just quickly, this is where we are probably headed as far as our infrastructure or architectural systems. Right now we have like still a few like several, not just one data source, but several, and it's probably gonna stay that way. Like, for example, we have the Postgre database for analytics, but we also have BigQuery that's also for analytics, but it's a little bit different, not I wouldn't say difficult, but different how to access the data there. There are peculiarities. There is probably a few more, and what we want to do is we want to have some unified, interface. Maybe we are just now thinking about using something like Dremio and other tools that could maybe help us do that, where people just have one tool to be able to query all the data sources we have, and it wouldn't be too difficult. It would be just much easier to learn than it is now. Also, we want to focus more on stability and monitoring, but that I already talked about. So I think that's all from me now. Yes, and probably now we can have maybe a few questions if anybody wants, or we can just have a break. Yeah, okay. And then Ondřej will continue with the streaming data. Okay, so there was a question.
Yeah, good evening. Thanks for the overview you've given us today. And I've seen that as the layer of the analytical database, you're stating that you're using a stack of database technologies. Have you looked into something more centralized, or maybe some solutions that encapsulate only or imply only one technology or one database or one analytical storage, like, for example, talking about Amazon Redshift or some other columnar storages like, or analytical storages like Snowflake? Or are there any particular reasons you have to use a stack to solve your needs?
Yes, I understand. We have probably tried, I wouldn't say all, but a lot of the solutions, at least briefly. Definitely tried Snowflake. We are probably still using it a little bit. Redshift, we definitely tried as well. I think we tried most of the known stuff, at least briefly, and some we are using, but not that increased, just a little bit. And yeah, maybe it might be easier to have one solution for everything, and maybe it might be possible, but what we found that no particular one thing is good for anything we do. So we are just rather using multiple things that are best for what we find is best, and then we find solutions how to put it all together. That's our approach so far, and it's been probably proven by us at least to be the most efficient one. But yeah, it's bringing extra difficulties, that's for sure as well.
Okay, thanks.
I think I maybe add something. Our current version, as Joe said, is that different databases have different attributes, and there is no one that would satisfy us completely. And in our vision, in long term, is to put another layer, like application layer, over all of the databases, so the user, like the analytic, which is our user, will have some kind of a way or use case how to query the data across all of the databases. I don't know the fancy term for putting some layer over different databases, but there is definitely one. Like I think
I know about term, but there is the tool I just briefly mentioned called Dremio, for example. There is more of them, and right now we cannot use them yet, because at least not in Dremio case, because they are not supporting Google Cloud and BigQuery yet, but we are in touch with them, and they are working on it. So it's probably in the near future when we can try this.
Okay, cool, thanks.
So I would like to ask, on what stage are you planning to implement Kafka, and for which use case would it look like? And what exactly implementation of Kafka would you prefer, either the native one or maybe Amazon Kinesis or something else?
Right now we are not using Kafka too much. We have been using it in the past, or maybe we are using it for one service, I think.
Two use cases. All of them are just queues. One use case for Kafka is that we use it for processing logs from some of the system, like DevOps-like logs. And another one is like application logs. If somebody is clicking in our mobile app or in website, we are collecting all these clicks, and with Kafka we are pushing them into the database. When database is down, it stays in Kafka. That's basically just a queue, and that's all I can recall.
Yeah, I think so as well, because usually I think we are testing it more previously, but in most cases it was usually Kafka or Redis, and Redis was the simpler solution. I think both were workable, but Redis was always simpler with maintenance or even mostly usage. And maybe I don't know, in a few cases maybe a RabbitMQ or so was able to we were able to use that instead. Probably just the ease of use was mostly the factor as far as I remember, at least. Okay, if there is no more questions. Okay,
yeah, one more. Thank you for your presentation. Could you tell more about ETL transformation process and how it works? Maybe you use some library or framework like Spotify Luigi or something else?
I'm sorry, I couldn't understand about what process?
ETL.
Exact
transformation.
Okay, and so our ETL is basically mostly, or not only, but mostly based on the Airflow system. Where is it, the slide? Just maybe if you could be a little bit more specific, what would you like me to talk about?
If you need to extract some data from your database, Postgres, and made it available in dashboards, how do you process it?
Usually, like the most standard type of process we have is that we have some source Postgres database, for example, from our booking team, and there is many tables that are not very good for analytics cases. So what we do is we asked, or in cooperation with the booking team, we implemented so-called updated add column into each of these tables, so that we know what we can synchronize. Also, we ask them to not do any hard deletes. They only do soft deletes if they have to, so because deletion is really hard to synchronize. And what we take the tables and basically move incrementally every 10 minutes or every hour sometimes data from their original table to our mirrored one in the analytical database. Basically, analytical database is really huge. It takes data from many databases. So we have a mirror of the table in our database. There is mirror of, I don't know, many tens of or maybe hundreds of tables. And then we do in our database to not do anything extensive on the production database. Then we do some transformation jobs, which build tables specific for our use, like for example the booking table, or we have a flights table and other tables like that. And then for the reporting, we usually have either it's simple, then we just take these tables, or if it's not simple, then we have dedicated tables, not for everything, but for the stuff that's more computationally extensive. You have a dedicated table, like maybe some aggregation, how maybe our partners or how us were doing on some routes, and the reporting is just built on top of this one or maybe two tables. So it's a simple join usually, or no join at all, because the table is specifically done for the specific report in case it's something more computationally intensive.
I may also add something more to the answer. Well, the most important thing about the transformation is that our analysts, they are used to work with pre-designed databases. And our production database, as I mentioned, we have grew really hastily. Our production database is not yet as good as it should be. So basically, our developers, me included, we have just hastily created some really badly designed schemas in the production databases, put some JSONs on that, and what should be in like 2 tables, we have it across 4 tables with lots of different JSONs around. So this is what analytics are not able to work with. So this is one of the purpose of the transformation, is to just traverse through a really different JSONs, gather the data about one booking to the one table, so they can do selects over the table. Just to mention that this is one way how to put the data in some frame. So it's all about selects in production database and storing them as a better designed schema into another database, which is analytics.
Yeah, it's mostly this Airflow. But Airflow, did you work with Airflow? Okay, so basically Airflow is just a kind of some sort of framework, I would say, or I don't know how to call it, but it doesn't give you too much, I don't know, functionality from the box. It just gives you a way how to write your own functionality in a good way, basically. But all the functionality, except very standard stuff, you basically just write yourself, but you write it in a way that it's good designed well. So this is what Airflow gives you. It doesn't give you transformation jobs, or maybe that gives you some basic copy jobs, yes, but we are not using that anyway. So that's not the purpose of Airflow. The purpose of Airflow is just to make you write good code, and everything fits together, and then also the visualizations, stuff like that. So that's why we are using it.
Yeah, all of the tasks you can see on the right side, it's just a Python code, which is usually doing some SQLs into the databases, but it is our own Python code.
I think there are a few more, or no, any more?
Yeah, I have a question. Thank you for your presentation. On one of the previous slides, they described the interaction between your system and another system like Moda, Skyscanner.
Oh yeah, it was on Andrei's presentation. Yeah, I cannot show it, but yeah.
No. Okay. Where was two letters and machine learning? Am I right?
Yeah. MN?
ML, yeah.
Oh, I don't remember it on my slides, to be honest. I can check quickly. It's not in my slides, so maybe it was in Andrei's. I don't remember it.
Yeah, I'll talk briefly about machine learning in my part.
Yeah. Okay.
But
so
if you have a question, you can ask.
Okay. And another question. Do you use some kind of cache system between different layers of your big system?
cache system.
Yes.
How long is its life? How it's what's the principle of invalidation of these caches? Is it between your customers on API, or maybe between layers exactly?
Now you mean in cache, like in a specifically case of the Airflow, just overall in the company, or what cache do you mean?
Okay, let's talk about external caches for your customers. As I understand, you have some kind of API, and there must be caches, of course.
Yes, this is true, and this is mostly, for example, on the front end on the search systems, they use caches or many caches, but I am not that extra familiar with the systems, so I'm not sure if I can really give you any more technical answer for that, or if you give me specific question, I may try, but I am not able to just describe the system.
Well, if I reformulate the question, are our search results cached somehow for our users? And I'm really not sure. I think there is some kind of Nginx-based cache, something like that, like on the uppest layer of that, but I've never ever put my hands on it, so I don't know how it works. But basically, all of our search results are made on a huge 1 hour cache.
Oh yeah, maybe.
You mean if we computed the results every 1 hour? So basically, what I have had on my slides, the Sky Store thing, it's basically a huge cache, about 20 terabytes of data of 1 hour data.
It's sort of
It's erased completely.
Yes, this is erased and computed again.
Cool. Thank you.
Hi, thanks for presentation. And how fast does system process data from the moment when data is scraped and to moments when customer can use it?
So you are asking when we scrape some data from an airline, for example, how often it can get into our itineraries that we offer to customers, right?
Yes.
Yeah. Again, this would be more a question for the developers who work on it, but we can at least try to answer. I think we have scraping modules that are running like almost continuously. I would say it depends. It's really it depends on the airline. Some airlines are scraped only probably like once a day, and some are scraped maybe every 30 minutes or so. But we are trying to scrape less and less. Like mostly with the bigger companies, what we do, we get some deals. Like maybe we pay them a little bit, or we just advertise them. I don't know really to get exactly, but they are providing us the data by different means and scraping it. Never mind. As far as this, when it's scraped, it almost instantly gets into our Cassandra database, and then the so-called SkyProf or SkyStore engine takes it basically, I think, hourly or something like that. So I think from the time when it gets scraped to the time when it get to our itineraries, probably something like up to an hour. I'm not sure, something like that.
Okay, thanks. And another question. Have you any bottleneck with Airflow, and maybe you say?
Can you say it again? Sorry.
Can you any bottlenecks with Airflow, or maybe you can say can describe some bottlenecks which you solve it?
No, maybe I didn't understand. If I can use a cell phone.
Bottlenecks in Airflow.
Bottlenecks.
If I bottlenecks in Airflow. Oh yeah, sure. Bottlenecks. I would say there is more than bottlenecks. There is multiple issues that we are having to I don't know, somehow address. One, for example, that has been a pain for us the whole time, and it still is that there is a basically Airflow. How it works? There is a in the first part of it, there is a scheduler that just keeps, just pushing all these jobs based on their schedule to several workers. We have right now, I think we have just 4 workers, 1 scheduler, and sometimes for some unknown reason I assume it's a bug in the scheduler code, but I cannot be sure 100%. But it happens that the scheduler just randomly stops doing this. It keeps working, like if you have it running in a Docker container in Rancher, but it shows everything fine, memory is fine, all the process is fine, but it just stops doing anything. Just no new jobs are being scheduled to the queue. There is actually a RabbitMQ for this, or Redis queue actually, yeah, Redis queue, and nothing happens, and it doesn't even give us any info about it. We also don't know.
I want to know where is the narrow places in the system. It is the source?
If it's the source, I'm assuming this is in the source code. Like there are, so I don't know for sure. It might be some problem on our side, but we don't think so because we are trying to find out and it didn't. So we just found some few workarounds. Like what we do is we restart this scheduler very, very often, and it works like that.
Okay, it's clear. Thanks.
Okay.
Hello, thanks for the presentation. So basically, I wanted to ask, since you experienced the same issue we've had with scheduler, so what version you are using of Airflow?
Of Airflow, I think 1.9.
The most latest, like
yeah, probably
1.9.0. Like we recently migrated to 1.9.0, and
I think this
we don't have this issue anymore.
Really?
Yeah. We were specifying num runs like 32 or something so it continuously restarting automatically before on 1.7, I guess. But with 1.0, we don't have this issue.
But I'm afraid we are having as well on 1.9.
Yeah, okay, but I wanted to ask another question basically. So presentation was good, but one topic I haven't quite understand is the data structure, internal data structure. So I think you have some kind of data warehouse, probably some dimensional model, schema, star schema, etc. So I would like to get some details on this and probably on the data lake part. Do you have it? Do you store raw data at all? Do you just keep it? Do you have some S3 storage? What kind of problems do you have with this? So how would you organize data warehouse part as well as the data lake part?
So I would say we probably don't have a data warehouse in the traditional sense of the word, or the name of the word. We have several basically, what we do is we have a so-called raw schema in our database, which contains all the mirrored table from all the other sources that we use. So there is really
so schema is like identical to the source schema.
There's a schema called raw in Postgres database. We made a raw schema, and the tables in there are identical to the original tables, with some exceptions.
And you're using columnar storage?
No, this is not columnar storage. This is PostgreSQL.
Yeah, so pure Postgres. I thought probably some custom version. But what was the columnar storage on?
For columnar storage right now we use BigQuery. And there we don't have that. We don't have, also Cassandra, yes, but this is not for analytical stuff. This is Cassandra is for basically our offer of flights. And I am not that familiar with it to be answering about this.
And given your data mass, do you have some performance issues with storing the raw data and everything else? How would you query it? I want to get some statistics, annual statistics of some, I don't know how users are using some section of the website during last months, given many criteria. So how does it work?
Yeah, so of course we have these problems, and of course they are coming again and again, but usually when something like this is a problem, what we do is we prepare an aggregated table specifically for this, or table or materialized view or something like that, that solves this problem or maybe an area of problems. So we just, if we know something like this is going to be repeated, like this question, and we create a specific source for that, that is recomputed every maybe 10 minutes or every hour, every day, and then the performance is fine. But yeah, then comes another problem and we have to solve it again. But yeah, that's I don't know, that's probably just how it is. But yeah, in the future, we'll probably be experimenting more with columnar databases that might, like for example, we are now using the BigQuery newly for analytical stuff as well, and it might at least not, of course it never will eliminate everything, but it will definitely help at least with some issues, I hope, at least that's what I would say.
Yeah. Thank you.
Thank you.
Thank you for your questions. Thank you, Joseph.